So hello everyone. Today we will finish some part in 1.4, the combination, and we are going to talk about the section 5, the multinomials. Okay, we left some part in the combinations. Actually, combination means n choose r, right? Let's just go through a little quick to review what is combination. So combination we use the notation this one, right? This one read n chooses r, and this one how to calculate this combination, that is n factorial, n minus r factorial times r factorial, right? That means in the total is n, you are going to choose r out of n. There are those number of different ways of combinations, okay? Different possible combinations we are doing. So in the combination, the important key or the different thing from permutation is the order does not matter, okay? If you choose always the same R object, no matter what is the order you pick those R object, so it's the same, okay? The order does not matter. So that is the notation for combination, and we read it n choose R, okay? N choose R. Now we are going to check the binomial series, okay? Binomial series. Let me just give the binomial series first, okay? Give the binomial series first, and we can do some analysis, okay? We can do some analysis. So here, the binomial series, we have two numbers, x plus y, okay? X plus y to the nth power. Of course, n is the integer, but x and y are not, okay? X and y, we don't have any specific restriction on that, but usually it's positive numbers, but it doesn't matter it's negative, okay? Just real numbers could work, or maybe rational number, okay? Rational number. So x plus y to the integers and to the exponent, that equals the summation, the sigma notation, k equals 0 to n, and we have this factorial, okay? We have this combination, n chooses r, x to the k, y, n minus k, y to the n minus k, okay? So we are going to analyze this one and try to just understand the proof from the combinatorial side, okay? Actually, there are two proofs provided in the textbook. They use the mathematics induction method. Mathematics induction method is widely used when you need to prove something, okay? And I remember I studied this induction method in my high school, but I'm not sure about you all. If you are familiar with this one, then you can read it in the textbook, okay? That is very strong logic to prove something in mathematics. So here we are going to start. We are going to understand this theory or candle proof, not exactly strictly proof, trying to understand this binomial theory from the combinatorial side, okay? So here first I'm going to do like if we have the term in this way, okay? If we have the term in this way, let's analyze first, okay? Analyze first. So if we have the term like, I'm going to write x1 and y1 in that way, okay? If we have this term, x1 plus y1 times x2 plus y2 times, if I have those kind of product, how many terms I'm going to get? This is the n term, n parentheses product, right? Here is n parentheses product. How many terms I'm going to get? So you can count in this way. So actually for each parenthesis, you need to pick one, right? For each parenthesis, you are going to pick one. You're going to pick either x1 or y1 in the first parenthesis, then times the second parenthesis. So you either pick one of them, right? You either pick one of them to form a term, and then the third parenthesis, you either choose x3 or y3. And then the last parenthesis, you either choose xn or yn, right? So that is similar, like you are going to form a term. You are going to form a term, one term with an object, right? A term with an object in each term, right? Here, a term means you will have one product, okay? One product in that way. So, for example, you can do x1 times x2 times x3. I'm not just talking about one term, okay? One term. Sorry, it's not plus. Sorry. It should be all go through the product. Sorry. So should be x1, just one example, okay? Just one example. You can take x1 times x2 times x3 times x4 until times xn. So in this case, which means you all choose x in each term. So how a term with an object times together. So how many terms like this one we are going to get? How many terms? This is a little abstract comparing to some specific examples we talked about before, okay? How many terms formed like this one? Think about it. How many terms we are going to form? So that means in each, the same again, in each parenthesis, you are going to choose one element. You are going to choose one object. Let's call those x, y, x2, y2, y, x2, y2 as object. Okay. So how many terms you are going to form? So which means step one, you are going to choose two. You are going to choose two out of I couldn't see any correct answer, okay? I couldn't see any correct answer here. So how many terms we're going to form? So you can do, for example, you can do x1, x2, or you choose x. So it's x1 times x2 times x3 times xn. Or you can do x1, and the other terms are all y. So you can do x1 times y2, y3 times yn. Right? So how many terms, how many different terms we're going to form? How many different terms? Which means in each parenthesis you have two different outcomes, right? In each parenthesis you have two different outcomes. Here, hey, when you answer the question, think about it. We have n, okay? We have n. So for the first one, okay? For the first one, you have two different choices. You either choose x1 and y1. And how about the second one? Second one, you either choose x2 or y2. You also have two different choices, right? Two different choices. And then the third one, you also have two different choices. And then the last one, you also have two different choices. What is this one? 2 to n. Here, if you still got confused, Think about this one. Y1, sorry. Think about the x1 plus y1 times x2 plus y2. In this way, how many terms you are going to get? You can have xy, x2. You can have different combinations. x1, x2, x1, y2, y1, x2, y1, y2, right? So how many different terms? 4, right? 4. 4 terms. Make sense in that way? So that means you can have those kind of, if you have xy, x2, which means in the first parenthesis you choose x. In the second parenthesis you choose x again. x1, y2, which means in the first parenthesis you choose x1. In the second parenthesis you choose y. y1, x2, which means here you choose y. Second one you choose x. y1, y2, which means each parenthesis you all choose y. So you have 2, 2, 2, it's 4. So can you tell me if you have x1 plus y1 times x2 plus y2 times x3 plus y3, how many terms? Can you tell me that? If we have 3 parentheses, if we have 3 parentheses product, how many different terms we are going to form? If you have 8, right? 8, because it's 2 to cube. Right? 9? How can you get 9? It's not 9, okay? It's 2 to the number. 2 to the exponent part. The exponent represents the number of parentheses we have, okay? The number of parentheses we have. So here, okay? So here, trying to understand, we have 2, 2, 2, 2, 3, okay? 2, 2, 3 case, okay? Now, let's look at the case I'm going to write here. Now, let's look at the 2 to 3 case. Okay, let's look at the 2 to 3 case. Okay, good. So, x1 plus y1, I'm going to analyze when n equals 3, okay? When n equals 3, which means you have 3 products, okay? You have 3 products. Maybe we are going to talk about the 3. When n is 3, that will be easy to understand. Then we can put the general case for n. So this means the 3 product, right? 3 products, 3 parentheses. So here we already analyzed for the, you are going to form different terms, okay? Terms. So the first parenthesis, you have 2 different choices. You either choose x1 or y1. You either choose x2 or y2 for the second one, right? For the third one. So we have 2 to cube, 8, which is 8 different terms, right? Terms. Now we know we are going to have 8. Now let's specify all those 8 terms, okay? So that means for the first one, okay? For the first one, you can choose x1, right? You can choose the x1. So let me write the 2 terms first, then we explain. We write the 3, n equals 3 again, okay? So let me write 2 terms first, then we can expand it the 3 case. So this one is easy, okay? Sorry, y2, y1. So it should be x1, y1 times x2, a2. This is easy, okay? This is easy. Let's start from here. So x1 plus y1, x2 plus y2, then we get 4 terms. That is easy, right? x1, x2 plus x1, y2 plus y1 x2 plus y2 y1 y2 y1 y2, right? So again, this is called two product when n equals 2. Two product, how many different terms we get? Of course, it's 2, 2, 2, so it's 4, right? Here we get 4 different terms, right? This one means 2 parentheses, you all choose x. The last term means 2 parentheses, each one you all choose y, right? This is, we starting from 2. Now, let's expand it when n equals 3. Of course, we will get 8 different terms. So you can use this term, use those 4 terms times x3 plus y3, right? Times x3 plus y3. So we can get that. Let's expand it. Please take note, okay? Please take note. So for the first term, x1, x2, then I can do, for the third parenthesis, I can choose x3, right? x3. And then I fix x1, x2 again, and for the third parenthesis, I'm going to choose y3, y3. And then I'm starting from the second term, x1, y2. For the third parenthesis, I'm still choosing x3, either x3 or y3, y2, y3. Right? That is this one. This second term, you either choose x3 or y3 to form 2 different terms, and then plus y1 x2 x3 plus y1 x2 y3. And then the last term, this term y1 y2, you can either choose x3 or y3. Same again, y1 y2 x3. And the last term means you all choose y in each parenthesis, right? So of course we get 8 different terms from here, okay? From here. So the first term means you all choose x in each parenthesis, right? The last term means you all choose y in each parenthesis. So this is the way how we read it. For example, this one, okay? This one means you choose y in the first parenthesis, you choose x in the second parenthesis, you choose y again in the third parenthesis, in that way, okay? In that way. So here we get 8 different terms, okay? 8 different terms. So that's what we said. If we have x1, so in this way, I think it's more clear, right? It's more clear to think about if we have x1, if we have n terms, okay? If we have n terms, x1 plus y1 times x2 plus y2 times x3 plus y3 until xn plus yn, we are going to get 2 to n different terms, right? 2 to n different terms. So everyone is clear? Everyone is clear? So in that case, okay, let me start one more, okay? Let me start one more. So in this way, sorry. How can I erase here? Okay, x1 plus y1 times x2 plus y2 x3, let me write more, plus y3, and until the last one, okay, until the last one, xn plus yn, in that way, right? So here, if you think about the 3 case, okay, if you think about the three product, it's easy to get it, okay? It's easy to get it. So here we have n product. Let me come back to the first one. So here n equals 3. for each term, if we're going to look at each term, okay, if we are going to look at each term, if I choose k, okay, if I choose k is a number, okay, if I choose, for example, if I choose 1, if k equals 1, if I choose k numbers of x, k equals 1, k numbers of x, I, then how many y I should choose? How many y I should choose? So if I choose 1x, that means I should choose 2 of y. Make sense? Is it clear? So if I choose 1 of x in each term, I'm talking about in each term, okay? In each term. So if I choose 1 of x, then I'm going to choose 2 of y, right? So what are those terms? What are those terms I'm going to mark in red color? 1 of x and 2 of y to form a term. So just 1x, this term, and this term, and this term, right? So if I'm going to choose 1 of x, 2 of y, I can have this term, and this term. And also if I'm going to choose 2 of x, how many y I should choose? Of course I choose 1, because each term we have 3. Each term we have 3, right? We have 3 elements. We have 3 objects. So I'm going to choose 1, right? I'm going to choose 1. So in this case, I'm marking green color, okay? So we have 2x, this term, and this term, right? 2x. So if I'm going to have 3x, what is the case if I'm going to have 3x? How about y? Of course, y is 0, right? 0 of y. What is this term? Of course, it's the first one, right? First one. I just mark it as a black color. And any other case? Any other case? We can have 0 of xi. And if we have 0 of xi in the term, how many y I should have? I should have 3, right? I should have 3. So in this way, I marked in the yellow color, which is this term, right? Which is this term. So you will notice that in the 8 terms, okay? In the 8 terms, you can do that. When you choose 0 of xi, when you choose 1 of xi, when you choose 2 of xi, when you choose 3 of xi. By the way, can you have 4 of xi? Of course, it's impossible, right? We only have 3 products. You're not going to form 4x in one term. We only have three objects formed in one term. Make sense? So the number of xi you can choose is only 0, 1, 2, 3. If your n is 3, if you only have 3 products. Make sense? And in another way, when the number of x you choose, as the number of xi you choose, the number of y is changing. But what is the rules? If you choose 1 of xi, that is you choose 2 of y. If you have 2 of xi, you choose 1. So which means, yes, you're right. We can't choose 4, right? So which means if you choose the sum of x and y you choose, the total should be 3. Make sense? The number of x and y you choose totally should be 3. 1x, 2y, 2x, 1y. If 3x, then it's 0y. If 0 for x, then y should be 3. Make sense? So the sum of all those numbers should be 3. Then if we can make a note, okay? If we can make a note, let k means the number of xi we choose, okay? The number of xi chosen. What is the number of y? What does the number of y mean? We know that the sum of the x and y should be 3 for the previous case. Now it's n. Now it's n. Number of yi's, we just write yi's chosen. Yes, it's right. N minus k, right? N minus k, because here you will notice that each term you are going to have an object, right? You are going to have an object. Of course, what are the possible values for k? What are the possible values for k? K can be 0, right? K can be 0 when you choose all the y. K can be 1. K can be 2. What is the largest value k can be? When k is n, right? K is n, which means we choose all the x. We choose all the x in each parenthesis. Now this is x1 times x2 times x3 times xn. Then how can we combine this term? How can we combine this term with the combination? So how many different ways you will have if it's k? If you choose k, think about it. You have xy, x2, x3 until xn, okay? You are going to choose k of those xn. For example, if your k is, let me check, can I write here? For example, your k is 1. This is the case. This is the case when your k is 1, okay? I just come back and forth because this is 3, it's easy to understand. So the red color, this is when k is 1. We have 1 xi and we have 2 yi's, right? So if k is 1, how many different choices you can choose? So for example, you can choose x1 as x. You can choose x2. If you choose x1, you get this term. If you choose x2, you get this term. If you choose x3, you get this term. But they are all counting in the red color, right? How many number? So that is n. 3 choose 1. Okay. What is 3 choose 1? Comma 3 choose 1. Okay. 3 choose 1. If you follow the formula, it's right. It's okay. 3 factorial over 2 factorial times 1 factorial. Actually, it's 3. Right? Actually, it's 3. And how can you get it a little quick? You have three objects total, but every time you just choose one object. Of course, you have 3 different choices, right? Get a quick answer, so that is 3 in that way. Make sense? So if you choose 1 of xi, then that is you have 2 of yi's, right? So it's the same way here. It's the same way here. And by the way, how can we write this one? How can we write this yellow one? We can write each one, okay? We can write each one. So the green one, the green case means you choose 3. 3 choose 2, right? When your k is 2. And then the yellow one means 0 of xi. My k is still the number of xi. So my k is 0, which means 3 choose 0. By the way, 3 choose 0, it's not 0, okay? If you are doing the combination, it's 3 factorial over 3 factorial times 0 factorial. This equals 1. And which means we have 1 terms like this. We have 1 terms, y1, y2, y3, like this one, okay? So be careful about the calculation of some simple combinations here. So what is the green one? What is the green one? You can check. Green one, we have 3. We have 3 terms, right? We have 3 terms. How can we calculate this 3 choose 2? 3 factorial over 2 factorial times 3 minus 2, which is 1 factorial, right? let's check the more general case. Okay, let's check more general case. So here we have the number of exercise chosen. So we are going to form how many different terms we are going to get. So for each term, we are going to have an object. How can we form those n object? So for those n object, I can choose in n, I can choose those different and choose k different combinations or different terms when you specify the k. Okay, when you specify the k, so you can get all those terms, right? This number of k. For example, if k equals 1, how many we will get? If k is 1, if k equals 1, which means the number we are going to have 1x, right? So n choose 1, the answer is n. How can we get those n different terms? You can have, for example, if k is 1, how can you form those n? So you can have x1, y2, yn. You can have y1, x2, yn. So you can shift your x all the ways. You only have one x, right? You only have one x. So you can shift those x until the last one. You can have the last term is y1, y2, y3 until yn minus 1 times xn. Of course, you have n different terms. That is what I said, okay? That is what I said. So n choose 1, you are going to have n different terms when you have 1x, okay? When you have 1x. But what are all the possible values for k? What are all the possible values k we can choose? Especially case, you can have k equals 0. What does k equals 0 mean? Which means there is no xi, so you choose all the y from one term. y1, y2, y3 until yn, right? That is the way when k is 0. And when k is 1, that is the case we listed. You just shift your x from the first place to the last one. And then when k is 2, what is the maximum? What is the largest value we can get for k? Of course, n, right? Because totally we can only have an object in one term. So when k is n, which means you choose in the term you have x, you have all the n xi's. How many number of yi? Of course, it's 0. So this term, when k equals n, that will be just 1, right? When k equals n, you only have one term. What is this term? You are going to have all the x. You only have one term. Make sense? So how many different terms? Now let me start a new page. I can only write 3. Oh, one more. Okay, one more. So for k equal to 0, you are going to have n 0 different combinations, right? Different terms. Of course, this means all, we don't have x, it's all y. So y1, y2 until yn. And when k is 1, then we are going to have these different terms, which means you only have 1x. We all list, right? You can shift your x1 shift to x2 until xn, so you have n. And when k equals 2, how many different terms we can form? And by the way, when you choose k of xi, then the other n minus k should be y, right? Here in this term should be n y's. Here should be n minus y's. Here should be n minus 2y's. If you have 2x, of course, you have n minus 2y's to consist one term, right? So in this case, we have we choose 2xi's, and then we choose n minus 2yi's to consist each term, but you are going to have n chooses 2 different terms, because you can choose those 2xi. It can be x1, x2, x1, x3, x2, x3 in that way, right? So all the way going, my k can choose the largest value n, which means in this case is n chooses n, which means you have n xi's. And in this term, in this kind of term, you don't have any yi's, right? So this is when 0x, 0 number of x, you have those different terms. This is when k equals 1, you have those terms, x equals 2. So how many different terms we are going to have? Your k, let me write in this way, okay? Let me write in this way. So those kind of different combination. So how many xi you are going to have? 0 to n actually should be x, there's no parentheses, x to the n, x to the k, times y to the exponent, y minus k. This term is a little different, okay? This term is a little different. Let's go back. Here all the x and y's are the same. So let's come back to the 3 case, okay? Let's come back to the 3 case. And we know this is x1 plus y1, x2 plus y2, x3 plus y3. Now, let me choose a different color. So if all the x they are the same, okay? If all the x they are the same, that becomes cube. If x and y they are same, if xi, yi are same, okay? I just choose a different color to illustrate the red color. If all the xi, yi they are the same, that becomes x plus y cube, right? X plus y cube. So if all the x they are the same, let's check the green color. Let's check the green color. What is the green color's term? What is green color's term? If all the x are the same and y is the same. So which means we have x squared, y. X squared, this is x squared, y. If all the x and y, they are the same, okay? X squared, y. Here, it's also x squared, y. So which means if they are the same, you can combine those 3 terms, right? You can combine those 3 terms. Now let's check the red color. Let's check the red color. So if all the x and y, they're the same, what is this one? This is xy squared. And how about this one? It's again xy squared if they are the same. And how about this one? Xy squared. Right? So actually from here you can know that x plus y cube actually equals x cube. This becomes x cube plus how many x squared y terms we have? 3. Plus 3x squared y, and plus how many xy squared term we have? Plus 3y xy squared, and plus 1 y cube, right? Make sense? So at the very beginning, we distinguish each one, each x and each y, okay? Now we combine, okay? Now we combine all those terms together. So we set up x and y, they're the same, so we can combine all those terms, okay? We can combine all those terms. So that is what I said here, okay? That is what I said here. So if all the x, at the very beginning, we did x1 plus y1 times x2 plus y2 times xn plus yn. So here it's x plus y to the nth. So for the x, you can have different terms when x is 0. When x is 0 to n, right? When x to 0 to n. But sometimes all those, for example, this term, okay, when k equals 1, I can write here, okay, I can write here. So for this term, if they are different, as I said, we can have x1, y2 until yn. We can have y1, x2, y3 until yn. We can have n different choice. If all the xi are the same, you can have this term. If all the x and yi's they are the same, you can have this term, right? So that is what we said, okay? So we set up what are all the possible values for k starting from 0 to n. We take all those terms as an addition, which we use the summation notation. So that is the final answer, okay? That is the final answer. We spend a lot of time, okay? We spend a lot of time to illustrate this one, okay? And you might read the textbook with the mathematics induction, okay? Mathematics induction to understand this part. If you understand this part in your high school, then it's pretty easy, okay? Then it's pretty easy. So here, that is what we considered at the very beginning, okay? What we consider at the very beginning. We consider this term, and then we are going to have 2 to n terms, okay? 2 to n terms. And we list when n is 2. If we have 2 products, we have those 4. How can we get those 4? It's 2 to 2, right? It's 2 to 2. And then how about the nth term? How about the nth term? Which means in the nth term, in each term, we have the n object. In each term, we are going to consist of n object. How can we choose those n objects? We are going to choose k xi's n minus k yi's, right? So in this way, we can set up our x. You can choose 0x n y's. You can choose 1x and minus 1 y's, and so on. You can choose finally nx and 0 y's, right? So that is we can represent as this way, okay? We can represent as this way such term, but our k can take all the possible value from 0, 1 until n. And then finally we set up if we let all the xi and yi they are the same, like I illustrated for x plus y cube, then we expand it in this way. Finally we get this term. That actually is the expansion, okay? Expansion. That is we call the binomial series, okay? Binomial series. And sometimes we call this n choose k. We call this combination actually as a binomial coefficient, okay? Sometimes we call it as a binomial coefficient. I guess it's mentioned in the textbook. Yes. So sometimes we call this one as binomial coefficient. The reason we explain the binomial case, we might use those in the binomial distribution. We are going to calculate the binomial coefficient in the binomial distribution when we introduce later, okay? Coefficient. This is also combination n choose r called binomial coefficient. So that is the series. Now let's look at a easy example, okay? Easy example. I think we already did it, right? We already did this one. Then how can we do this one? Actually in that slide, so x plus y cube. Let's come back to here to my note. So how can you expand in x plus y cube? So if we let all the x and y's they are same, I'm going to answer. I know it's a little messy for my note, okay? I just continue here and you have all the notes here. So here you can take that. If you expand in x plus y cube, this term becomes x cube, right? This term. And then you are going to have 3 terms for green color, right? 3 terms for green color. And the red color, you will also have 3. X, Y cube. And what is the final one? The final one should be Y cube. So it's easy, right? It's easy. And we can also follow that, okay? We can also follow the binomial series to expand it. Yes, I mean, you have already know how to expand this cubic term, right? How to expand this cubic term. But we are trying to understand this one from the binomial series, okay? We just follow the formula from binomial series like that, okay? So this is the case. Just think about when n, this is when n equals 3, right? When n equals 3, so we can follow the binomial series. My k can be 0. Just remember, this k represents, you can choose the number of x, right? The number of x you can choose. Then that is the combination n, sorry, 3 choose n, right? 3 choose n. 3 choose n. 3 choose k. Then it should be xk, which represents the number of x you have in each term. And then if you choose k of x, then you are going to have 1 minus k of y, right? So we are expanding when k is 0, when k is 0, we have this summation notation, which means you take the sum. So when k is 0, you have x0. When k is 0, so here should be 3. Here should be 3. My n is already specified. It's 3, right? It's 3. We already analyzed this part in blue color in the previous page, but we just follow the binomial series to work out this one and to check, okay? So this term means how many number. Let me write all those. Let me expand those and explain what are those, okay? Following the combinatorial perspective. So this is when k is 0, and when k is 1, you have 1x. So my k is 1, then I have 1x, so I should have 2y. And then next, I'm going to have 2x, so it should be x squared. I'm going to have 2x, so I should just have 1y. And the last term is when k equals 3, I'm going to have x cubed. X cubed, what is y? Of course, no y, right? No y. So how can we understand this one? This one means you form the term y cubed. Here, the x to the 0, this term is 1, right? So if you have all the y cubed, how many possible choice? Just 1, right? Just 1 times y cubed, because this is 0. And also you can use the combination formula to evaluate it. What is this one? This is 3 factorial over 3 minus 0 factorial and 0 factorial, okay? For the combination, okay, for some simple combination and choose R, I think if you understand what does this notation mean, then it will be a little quick, okay? So here in the probability, okay, we are not just doing calculation, okay? In the probability subject, the difficulty is not you calculate something, okay? It's not you calculate something. I believe everyone in the class, they are able to do those factorial. They are able to do all the calculation. But the important part is whether your calculation is right, whether you get the idea of the problem, whether you understand what is the combination the question asked. That is more important than doing the calculation, okay? So here, we understand if we choose 0x, we only have one choice, which is 1. And then here, what does this one mean? This one means I choose 1x and 2 y's, and I put in some color in red or green. So I put some colors, okay, in one page with my note. So this one means you choose 1x. So you are going to have y squared. So how many choice? Of course, you can think about it. You can have x1, y2, y3, y1, x2, y3. Or you have y1, y2, x3. Of course, it's 3. So this combination is 3. Which means out of 3, you choose 1. How many different choice? 3, of course, without doing those combination formula. So that is 3. Okay. And how about 3 to choose 2? 3 choose 2. 3 choose 2, it's the same. Or if you don't believe me, just do 3 factorial over 1 factorial times 2 factorial, which is also you get 3. Because here, x squared times y, which means you can shift your y. You can have y1, x2, x3, or you can shift your y2. You have x1, x3 times y2, or you have x1, x2 times y3. That's why you get 3. That's why you get 3 different terms here. This number means 3. Then 3 choose 3. 3 choose 3, which means you choose all of them together. Of course, you only have one choice. You put all of them together, right? You choose all the x together. Of course, this y to 0 is 1. So that is how we expanded it. And usually we would write in this way. 3x squared, put the decreasing order for x terms, okay, for the x exponent, and the increasing order for y exponent in this way, okay. So this formula is easy without the binomial series knowledge. I believe everyone knows this cubic equal to this one. But how can we understand the expansion? How can we apply the binomial series in this way? Then that is important in this part, okay. So that is the part we left in section 4, and I guess we can take a break. Then we will start the section 5, okay. Let's stop here for section 4.